I'm Lena.
I'm Sandra.
We are analyzing the San Francisco Airbnb dataset. Inside Airbnb collects public data from the Airbnb website to conduct analyses. The dataset given for this project is a random subset of Inside Airbnb data from San Francisco collected in June 2020. The listings table provides information on 2,000 Airbnb listings, with each row representing a different listing. The calendar table contains information on each of the 2,000 listings, availability and price for each day that they're listed, and the duration of 1 year. Whether South Market is an expensive neighborhood to live in has recently been a very controversial issue. Some believe that as tech startups have entered the area, the cost of living in SoMa is also on the rise. To further analyze this, the hypothesis question that we want to examine is whether the average price per night of apartments in SoMa is more expensive than those in other neighborhoods in SF, with the null hypothesis being that the average price per night of apartments is not more expensive than those in other neighborhoods, and the alternative hypothesis being that the average price per night of apartments in SoMa are. Relatedly, we wish to predict the average price per night of an apartment based on the number of bedrooms it has, and to do this, we'll use linear regression modeling.
We intend to perform an A/B test for our hypothesis testing question with SoMa apartments in Group A and non-SoMa apartments in Group B. First, we want to look at the distribution of apartments in our sample. The table to the left summarizes how many apartments are in each neighborhood in our sample. We see that there are 35 apartments from SoMa. Though this is a small proportion, as long as we repeat the shuffling process for many times, every apartment price average still has an equal chance of being assigned in either group. The table we will use for our A/B test is shown on the right, with one column indicating whether an apartment is in SoMa and one column indicating the price average of the apartment. We obtained this table by first manipulating the calendar table to obtain the average price per night of each listing. Then we join the data with the listings table with selected variables of interest. We then check on how the price average of SoMa apartments compare to non-SoMa ones. In the qualitative plot to the left shows the average of price averages of apartments in each neighborhood in our sample. We can see that SoMa apartments are on average more expensive than apartments in most other neighborhoods. Though there are some neighborhoods above SoMa, our data set contains very few apartments in those neighborhoods. The lack of data points implies that these neighborhoods being higher on the chart can simply be due to chance. Therefore, our hypothesis testing question is still worth investigating for. To the right is our quantitative plot showing the relationship between the number of bedrooms and the price average of apartment. There seems to be an underlying linear relationship that we can utilize for our prediction model, but we will still have to investigate further in order to make this claim. We intend to use an A/B test to verify whether apartment listings in SoMa have higher price averages compared to those in other neighborhoods in San Francisco. We choose a 5% cutoff, and the test stat is the difference between the average price averages of SoMa and non-SoMa apartments. We then computed the observed stat and run a simulation of test stat under the null. Our p-value turned out to be 3.76%. Using the 5% cutoff, we conclude that SoMa apartments are indeed more expensive than non-SoMa apartments. For our prediction section, we try to fit a linear regression model as shown in the plot to the right to predict the price average of an apartment based on number of bedrooms. The R value generated was 0.54, which suggests a moderately strong positive linear relationship. The residual plot shown on the left suggests that the predicted price average for an apartment with 0 bedrooms tend to be higher than its true value. Despite of this observation, we still believe that a linear relationship is worth investigating for. To account for the variability of our prediction, we found the 95% confidence interval for our model's prediction of price average for a 3-bedroom apartment. Using Bootstrap, we generated the empirical distribution of predictions which contained our observed prediction. We therefore conclude the predicted price average for a 3-bedroom apartment will be approximately $305, even if we draw a different sample from the population. Similarly, we computed the 95% confidence interval for the slope of the true line, which did not contain 0. Hence, we conclude that there is a linear relationship between the two variables.
By using A/B testing and a 5% p-value cutoff, we showed that apartment listings in SoMa do have higher price averages in comparison to those in other neighborhoods in SF. Also, based on the regression model we generated, we predicted the price average for an apartment with 3 bedrooms to be about $305, which lies within the 95% confidence interval of predictions. Additionally, we computed a confidence interval for the slope of the true line, which allows us to conclude that the true slope is non-zero. A major limitation with this data is the spread of COVID-19 could heavily impact the pricing of each Airbnb listing. To account for this, it would be really interesting to research pre-COVID data with the data set that we currently have.